I know this says 3.3. In the book we used to use, it was 3.3, and I just never bothered to change it. It's actually 5.3. Just as a reminder, if f is positive on an interval, then f is increasing on that interval. And if f prime is negative on an interval, then f is decreasing on that interval. So this leads us to the first derivative test for local extrema, which says that if c is a critical number of a function f, which is continuous on an interval containing c and differentiable on the interval except possibly at c, if f prime changes from negative to positive at x equals c, f has a relative minimum at c f of c. And if f prime of x changes from positive to negative at x equals c, f has a relative maximum at c f of c. So, for example, the graph of the derivative y equals f prime of x of the function f of x, I guess I should have said is given or something. It's not really a sentence. Find the x-coordinate of each relative extrema of f of x. So, we first of all look for critical points. The critical points of f are where f prime is either 0 or does not exist. Well, f prime appears to exist everywhere on this interval that it's shown, but the three critical points will be x equals b, x equals d, and x equals f. Those are the places where the derivative is equal to 0. So at x equals b, f prime changes from positive to negative. Which means that f changes from increasing to decreasing. And if f changes from increasing to decreasing, what has to happen where it changes from increasing to decreasing?
There's a nil, extremum.
If it changes from increasing to decreasing, there's a maximum. So f has a local maximum. Should have written smaller to start with. What about at x equals d? Well, here, notice f prime does not change sign. Since f prime does not change sign, f has neither a local minimum nor a local maximum. And then at x equals f, f prime changes from what to what? So I heard two different answers, and one was right and one was wrong, and it's a really easy mistake to make. When you're looking at the graph of f prime, if you want to know about the increasing and decreasing behavior of f, you need to look at where f prime is positive and where f prime is negative. So f prime changes from negative to positive. Right? F prime is negative here, f prime is positive over here. Therefore, f changes from decreasing to increasing. So f has a local min. Now, in practice, what we're going to do is this middle step that I wrote on the first one and last one, we're not going to write that out, but I wanted to write it so that you could think about, oh, this is why this works. That is what this theorem says. Okay, but I just wanted to emphasize, well, why does that work? Okay, we're going to use this quite a lot. All right, so let's find the intervals on which f of x is x cubed minus 3 halves x squared is increasing and where it's decreasing. Okay, so I'll take the derivative, f prime of x, which would be 3x squared minus 3x, and I want to find its critical points. Remember, critical points are where the derivative is either 0 or the derivative doesn't exist. My suggestion to you is make yourself always think first about where it doesn't exist. Thinking about where it's 0 is very natural. Thinking about where it doesn't exist, it's easy to forget that. Is there a place where this derivative doesn't exist? No. So I'll just find where it's equal to 0. Factor a 3x out. And I get x is 0 and x is 1 are my critical points. Then, as a help, it does not count as justification. I'll look at what happens to the derivative. So if I pick any value of x less than 0 and I substituted it into the derivative, and by the way, it's always fastest to check whether this is going to be positive or negative by factoring into the factored form rather than the other. So let's say I pick -1. The 3x will be negative. The x minus 1 will likewise be negative. Multiply those together and I get a positive. So I get f prime is positive here, which tells me what about f? If f prime is positive, what do we know about f? Pardon? Increasing. Yeah, I just heard increasing, and I'm like, what? Yeah, f is increasing. If I pick a number between 0 and 1, let's pick 0.5. The 3x will be positive. The x minus 1 will be negative. So f prime will be less than 0, which means that f is doing what? Decreasing. And if I pick a value larger than 1, say 2, substitute in, I get a positive times a positive, f prime's increasing, or f prime is greater than 1, so f is increasing. So f is increasing on open at negative infinity but closed at 0, and closed at 1, open at infinity, and f is decreasing on the closed interval from 0 to 1. Unless the function doesn't exist at the endpoints, increasing, decreasing intervals are always going to be closed intervals. Okay? All right. So let's go on to talk about the local extrema. It just wants to find the x-coordinate of each local extrema. This is more how they ask it on the AP exam. In their book, a lot of times it says find the points of each local extrema, and I'm like, okay. Or it doesn't specify. So let's take the derivative so that we can find any critical points. That's going to be 1/2 plus sine of x. On the interval from 0 to 2 pi, is there any place where that doesn't exist?
0 and pi.
Pardon?
0 and pi.
Where it doesn't exist?
Oh, sorry.
Yeah, it exists everywhere, right? So we'll set that equal to 0, so that means sine of x is equal to negative 1/2. Which means x is equal to what two values?
Sine inverse of negative 1/2.
You're gonna have to be a little louder if you want me to hear you.
Sine inverse of negative 1/2.
Yeah, okay. So where is that? Unit circle?
5 pi 6.
At 5 pi over 6, sine is positive. Sine is positive in the second quadrant.
7 pi over 6 and 11 pi over 6.
What was the first one?
7 pi over 6.
Yep. 7 pi over 6. And x is equal to 11 pi over 6.
I could do it.
So do you use the hand trick?
Yeah, it's like square root of 3, 1 over 2.
Yeah.
2 over 2, 1 square root of 3.
Okay.
Like,
And then it's just a matter of thinking about, well, where is sine positive and where is it negative? All right. So again, I'll use a little number line, except I'm not going to put arrows on it this time because I'm only going between 0 and 2 pi. There's a huge gap, right? We're more than halfway over in here. If I pick anything between 0 and 7 pi over 6, well, pi seems like an easy thing to use. Sine of pi is 0. Plus 1/2 is positive, so here f prime is positive, so f is increasing. Between 7 pi over 6 and 11 pi over 6, what would be probably the easiest thing to use? 2 pi over 2? Oh, I thought you said 2 pi over 2. I was like, what? Yeah, 3 pi over 2. At 3 pi over 2, sine is negative 1 plus 1/2. F prime negative here. So f is decreasing. And after we get past 11 pi over 6, although we're stopping at 2 pi, we could keep going, right? Here, as we get close to 2 pi, this gets close to 0 plus a half. So f prime greater than 0, f is increasing. So f has a local max at x is 7 pi over 6 because f went from increasing to decreasing. And f has a local min at x is equal to 11 pi over 6.
I hate writing 11 pi over 6. Because I always write that 1, 1, and then I just go straight to the line on top and then like go backwards.
I can see that. All right, let's try this one. A little bit more complicated graph. These other ones aren't too super complicated. This one, I have no idea exactly what this looks like. So I'll take the derivative. How do I take the derivative of this? Outside first. So that's 2/3 of leave the inside alone times the derivative of the inside part, which is 2x. So it's probably worth your time to rewrite that as 4x over 3 times the cube root of x squared minus 9. Where does that derivative not exist?
3 or -3?
Yeah, 3 or -3. Now, before we go on, does the original function exist at 3 and -3?
Wait.
Not -3.
Why not?
Oh, sorry, cube root. Never mind.
Yeah, you're taking the cube root of 0, which is 0. Does this function exist for values outside of -3 and 3? Like, for example, or inside? It's like, does this exist at x is 0, the original function?
No, because you can't take this. Oh, no, you can't take the cube root.
You can take the cube root of a negative, so it's all good.
Yeah.
So these are critical points. Where is f prime going to be equal to 0?
9 or 3.
No. I'm looking at f prime. What makes this 0?
Oh, 0.
X is 0, right? I just need the numerator to be 0. So I've got 3 critical points this time. That really fell off at the end. Let me try that again. All right, so if I pick a value less than -3, and again, I'm looking at the derivative. So let's say I pick -4. My numerator will be negative. My denominator, if I take -4 and square it, I've got 16 minus 9, that's positive. Take the cube root, that's still positive. Times 3, that's still positive. So here, f prime negative. Between -3 and 0, I'll pick 1. My numerator will be negative, but my denominator will be negative also. So here f prime is positive. At x is 1, my numerator will be positive, my denominator will be negative. So f prime less than 0. And if I pick some number larger than 3, my numerator will be positive, the denominator also positive, so f prime greater than 0. By the way, these do not always just alternate. More often than not, they do, but not always. So don't just find the first one and just assume that it alternates back and forth. It doesn't always.
Would that be a safe bet if we're running out of time on the AP test?
A safe bet? No.
Be
A bet that I would make, knowing that I'm running out of time? Yes. All right. So f has what's it going to have at -3? Well, if f prime goes from negative to positive, f goes from decreasing to increasing. So f has a local minimum at x equals -3. What about at 0? Yeah, f has a local max at x is equal to 0. What happens at 3? Another local minimum. If memory serves, which is a dangerous thing at my age, this graph looks something like this. Pardon?
It's funny looking.
See a turtle.
I always think it looks like the top of Shrek's head.
Oh,
That's it.
that it really does.
Or like Green Goblin.
Oh, yeah?
I can't unsee Shrek now.
Yeah.
I was going to say, once I say that, you're never going to be able to unsee it.
I saw a turtle's head on the left side. And I saw the little shell.
Oh, I kind of see it.
If you do it on the graph screen, it looks more like a W. Anyway, we will move on. Just one more. X to the 4th plus 1 over x cubed. And we want to take the derivative of that.
Make it not a quotient.
Okay, let's make it not a quotient. How can we make this not a quotient? That's an excellent idea.
X to the 4th plus 1 times x to the -3.
Okay. Let's make it even better. Let's not even have to use the product rule.
Okay, let's do that.
Would it be x plus 1 over x cubed?
Yes. X to the 4th divided by x cubed is x. And 1 divided by x cubed is x to the -3.
Saved a lot of time there.
Yes, if you can simplify the expression before you take the derivative, it is almost always to your advantage. So f prime of x is 1 minus 3x to the -2.
-4.
Oh, sorry, -4. Oh, where does f prime not exist?
0?
Yeah. Does f exist at 0?
No.
Nope. That means we can't have a minimum or a maximum at x is 0 because the function doesn't have a point at 0. Now, is it still important to recognize? Yes, because you can't have a change in behavior across that. All right, so this is going to be 3 over x to the 4th is equal to 1. So x to the 4th is 3. So x is the 4th root of 3. And it could be positive or negative, couldn't it? All right, so I want to include 0, the negative 4th root of 3, and the positive 4th root of 3. And that looks like that's part of the root sign, so I'll stick a negative up there so it's clearer. And you're like, okay, man, I really don't want to check this. Let's start checking on the positive side. So, I can pick any number I want as long as it's bigger than the 4th root of 3. And you're like, I don't know what the 4th root of 3 is. All right, pick 100. Are you pretty sure the 4th root of 3 is smaller than that? Yeah. So if we had 1 minus 3 over 100 to the 4th, is that going to be positive or negative?
Positive.
It's very much positive. And then occasionally I have students who freak out at this point and they're like, I don't have a calculator for this problem. I can't find this. I'm like, I didn't ask you to find this. Well, how am I supposed to know what number to pick in here? Well, do you agree that the 4th root of 3 is bigger than the 4th root of 1? So 1 would be a great test point. And when I substitute in 1, I get just 1 minus 3. So here f prime is negative. If I substitute in -1, well, since it's to the 4th power, it's still going to be negative over here, isn't it? And then over here, I'm going to have f prime positive again. So f has a local what at negative 4th root of 3? Yeah. Max at x equals negative 4th root of 3.
They're facing in, there's a local.
Pardon?
If they're like facing in, there's a local.
If they're facing in, oh, okay. If they're facing in, it's a local min. If they're facing out, it's a local max. It's, oh, if they're facing, it's too bad it doesn't rhyme.
Yeah. Well, if I remember one, then I'll know the other one's just opposite.
All right, and then f will have a local min at x equals positive 4th root of 3.
Why does the function f prime not exist at x equals 0?
Because I can't divide by 0?
Oh, it's negative 4.
Yeah, it's to the negative 4th power. So this is going to have a vertical asymptote at 0. is what's going to happen. All right.